And it tells me, okay, it looks like it's recording now. Yeah, so what I posted there, let me, I think I have it up still over here. No, not that one. Actually, I closed it out, so let me go ahead and pull it back up so that we can see it. So, and I'll share it for the, I'll share it briefly for the recording to be able to see what we're looking at here. Right. So, so Snopes is it's a fact-checking site. It's something that I keep up to date with. I don't really want to get into. I don't want to get into anything political about this or anything, but you know, because obviously what we have here is we have one group of people who are claiming that because there was a reported glitch, a reported bug in the software of the vote counting system, that apparently, I believe in this particular story, it talks about how what is it, that basically after the glitch was found, many of these votes that had been counted for the Democrat candidate switched over to the Republican candidate, and it ended up being that, if I remember correctly, the Republican candidate ended up winning the election because of this glitch that was found. So you have, you know, one side that one group of people who are claiming that there was this voter fraud, that it was actually a planned thing or whatnot, and then you have another group of people who are saying that, oh no, it's just a software glitch. And then later on, it was reported that, as Alper, as you brought up, that then the blame seems to have been shifted to this person that I believe they don't name the person, but they said that they did not update the software properly, and for that reason, this glitch was found in there. So again, I don't want to get into any of the political debate about that, but what I find interesting is, as soon as I saw this story, because I didn't see it on Snopes initially, I saw it on a news website initially, and my first thought was, this is exactly why we need quality software, why we need to have systems in place to make sure that our software is trustworthy, because and to realize that even some of those systems won't be technologically based, that some of the parts of the system will be, maybe we might have a situation where a person, a user, a customer has to update frequently in order to not get caught, right? In order to not get caught with bad software. You know, earlier today, for example, I was getting ready to teach my morning class, and about 10 minutes before the class started, I got this little message pop up, and it said, you know, oh, you need to restart the computer for this update to take effect. And I said, okay, fine, whatever, I'll do that. I got 10 minutes. So I clicked OK, and next thing I know, 30 minutes later, I'm still waiting for the computer to finish restarting, right? And I'm like, I've got to teach this class. I'm 20 minutes late to teach my class, and it's still waiting. And then the computer came up, and initially Microsoft Teams had a bunch of issues where it wouldn't start properly, and I couldn't start the class right, you know. And so so what I'm getting at is, you know, that our software, if we don't have quality software, if we don't have something in place to make sure that it's tested properly, that it's that we have confidence in it, then we can end up in the news, like this Dominion software company, that apparently this software, this vote counting software, is used in America in over 30 states, 30 of the 50 states in America. And so that this whole, somewhere in there, whether it was the technical glitch, whether it was the person that didn't update it properly, whatever may have happened there, it can look like really bad on the part of the software development company, and it can have other effects as well. The truth is, if there is no voter fraud at all going on, the fact that this error happened at least causes suspicion, right? Can at least cause some suspicion on the parts of whether or not, this really big thing, an election of people senators and Congress people and President of the United States, can be cast into doubt, all because of, one small little bug that was in the software, so just when we sometimes think, oh, it's not that big a deal, I don't need to test it, or, stuff like that. Yeah, I do have another story I want to send you guys as well. Another that I mentioned it briefly before, and I realized I need to probably make myself a note. Actually, what I may do, I can't do it here. I want to make myself a note for this because a similar issue with software problems resulting in lack of confidence in the system happened. It's also in America. It's my home country, so I have a lot of stories from there. But it had to do with the what they call Obamacare, or the Affordable Care Act, when it first rolled out a number of years ago. I would like you guys to take a look at that as well, to also see another place where software, if we try to meet the deadline without ensuring quality, and we can even do things sometimes that actually cause problems. So in that particular story, one of the things that caused a big problem was the project was behind schedule, and so they added a bunch more programmers to it. And I think we mentioned this before in a previous meeting. So yeah, so I'll find a link to a good story about that one and send that out to the class as well. So, all right. So other than that, there was another. I also sent the paper about the Ford Pinto case as well. I created a new channel for this class called, I think it's called Reading Links. So anything that is a paper, like a PDF paper that I can put, that I'll want you guys to read, I'll put inside of that readings folder that's in the class materials. But if I can't find a paper, if I can't find like a downloadable PDF for it or something, and I may just have like a news article or in this case like the Snopes article, or this other one about the Ford Pinto case, I'll just post the link as a conversation into there. So that's for you guys to take a look at, and it's all, for most of these, it's going to be in some way or another related to how software, whether a lack of quality resulted in decreasing confidence in our field and what we do, or I'll try also to find good examples of times where good software quality practices resulted in increase in confidence, because that's what we'd like as well. So, all right, so you guys were supposed to. I posted the configuration management slides for you guys to take a look at. Did you guys look over those before today?
Yeah, I took a look, but not a deep reading.
Okay. Tahir, did you take a look at it?
Actually, no, I didn't know I was supposed to do.
Okay. So what I decided was, for this class, I'd really much prefer it to be more of a kind of a discussion-based class. And I think I even said last week, I'd prefer to get out of the habit of calling it a class, even though it is more of like a meeting for us to discuss these ideas. So this particular week, the topic that is on the schedule is this configuration management. And basically the idea behind configuration management is the use of tools so that we can have an idea of what the software looks like, what the system, not just the software, but the system, even, what it is like, capturing those snapshots at discrete points in time throughout the development process, so that if we get to a place, so there's multiple reasons why. One is if we get to a place where we encounter a problem, where we've injected a bug into the system, where there wasn't a problem that existed through our development, we added a bug to the system, we can roll back and go back to a previous version of that software, or even of that, if that component, if it's a system made up of multiple components, and we can go back and be able to revert back to what it was before before the bug was injected into the system. So if you've ever, I mean, I'm assuming, have both of you used GitHub at some point? Yeah. Yes. No.
Yes, we used GitHub.
Yeah. So GitHub would be a type of version control system that would be a configuration management tool. It's this. I mean, it's the same idea, right? You when you make a change, you can upload your change into the system, and then it gets added to the whole thing, right? So it's a way for people to share their systems. Now, I haven't used GitHub much, honestly. I've used it some, but not enough to really have a solid understanding. But I would imagine we wouldn't necessarily call GitHub it wouldn't be a very strict version control system, because, so I'll just tell you kind of in my experience. So if there was a version control system that we used in the last company that I worked for, and what would happen is there was the configuration manager was in charge of the whole thing, the whole system, the components. He couldn't write any code. He wasn't a programmer. He was actually a business guy, but he wasn't a programmer, so he didn't know anything about the code itself. But what would happen is I would have like some change request or some code that I needed to change or whatever. And what I would do is I would realize that, okay, let's say this particular file or this particular screen needed to be altered. It needed to be changed to satisfy that request. What I would do is I would write up a, it's been a while. It's been a number of years since I worked there, so I'm trying to think of the name of some of these things. But basically, I would write up a request. I would write up a document that would say, you know, this is this is the file that I need access to. Because up to this point, up until I sent him this message, I have only only access to that file. So I can't make any changes to it, but I can see it and I can look at what the code says already. So I say, okay, I need to make a change to this file. I'll send it to him. Part of that document that I had to write had to connect back to a design document. And usually what it would have to do is it would have to connect back to a design document and the section in that design document that it connected to. So this was part of this process, was to be able to connect any code changes that we made to the design requirements, and then the design document, when we had written those, would have been connected back to the requirements document. So we have this chain, right? So this requirement generated this design specification, generated this change request on my part. So I send him this email. I send him this document that's a change request. He keeps it in his folder and his however he's organizing. And all he does is he says, okay, Joseph said he wanted these 3 files, whatever they were. He goes into his configuration management tool. He clicks on those 3 files and he releases them. And what this means is that well, actually, technically, when he releases them, anyone can have access to them. So suddenly at this moment, anybody could go in there and take those files, right? But what would happen was he would immediately say, okay, I've just released them, you can go get them. Then I go into the configuration management tool, I click on those 3 files, and I click on checkout. Now, what happens when I click on checkout is it locks them to anyone else. I'm the only one that can make changes to them. All right. So this is a control system so that not only before this time, before he released them, I couldn't make any changes. No one could make any changes. All right. So we have this. If you looked at the slides, there's a section here talking about a baseline. So right now we have, let's say we have in the version control system, we have this baseline that exists there. So he releases them. I check them out. Now I'm the only one with access to them. This means that if a coworker needs to make changes of their own to the same file, they have to wait till I'm done with it. So they can't go in and make changes at the same time that I'm making changes. And so there's a lot of control that's going on to make sure that these things are done well. All right. So then once I'm done making the changes, I do my unit testing, making sure that it works as far as I can tell. I submit into the repository. I submit the file back into the repository. I release it. Now, so now it's my job. Now I have to release it, which then again makes it available to anyone who might need access of it, or anyone. I shouldn't say that. It makes it available to anyone. And then I tell the configuration manager, I say, hey, look, I'm finished with my changes. You can go ahead and lock it back. He immediately locks the files back so that no one gets access to them. And then later, once that's done, then we move on. Once all of our changes are done, we move on into the testing phase to make sure that the submitted changes are good. Right? But the whole purpose of the whole configuration management is to just make sure that things are controlled, that I only have access to those files that I need to have access to. And we also have in there, what is it I'm thinking of? A record. Like we have there's a word we use, it's a phrase we use called a paper trail. It's not so much things are done by paper anymore, but the whole idea of a paper trail is having some record, some set of documents or documentation that shows how things were done. So basically, if after I've submitted my changes, through the follow-up of the system-wide testing that happens if we realize that that a bug was introduced, we can at least narrow it down to those documents, to those code files that were checked out during that build. All right, so we don't have to go look through the whole system to figure out why this one bug got introduced, but we can at least narrow it down to it's somewhere in one of these, X number of files that were checked out. Right. So we have a record of what was done. So did either one of you, so the class that I taught earlier today was system administration. Have either one of you ever done a system administration course, Linux, that kind of stuff?
No, actually not. But you are the responsible lecturer for that course as well, right?
That's right.
Okay. No, I didn't.
Okay. Yeah. The reason why I ask about that is because so in Linux, there's do either one of you use Linux or have used Linux?
I had to, unfortunately.
Yeah, I had to learn how to use Linux to teach the system administration course. I've never used it before either. Although I'll tell you what, after this morning's experience with Microsoft Teams, I'm thinking Linux might have been better anyway.
Actually, you could have postponed updates. It doesn't force you to update immediately.
Yeah, I know. I just thought it was gonna. I thought I had 10 minutes left, so I figured I'll just do it.
And also, let's say we postponed, and it's gonna come eventually. Like there's no escape.
Yeah.
You can postpone it, but for how long? For how many times?
Start it before you go to bed. It's best.
Yep. You're right.
No, and for example, I used to study at library when I was in bachelor's times, my first years in universities. So in library, for example, it's late and I'm studying and I need to go to home or I need to catch a bus. And just when I was trying to turn off my computer, it says updating. And I cannot put it in my bag while it is updating my laptop. So it's Like I really hated the experience. I remember myself like trying to catch a bus with my laptop on my hand, doing Windows updates. The, even
But
even if you,
you can cancel automatic updates and do it manually. There are options if you check it out.
it wasn't available at that time. It is it has
Windows
just
XP.
no, not XP. I'm talking about when Windows 10 in 2015 it wasn't a thing. You were not able to do it manually. Now you have the chance to do it manually, but if you don't do it for 6 months, for example, for a long period of time, it still does it automatically.
Yeah, and there are some what they call, what are the like especially the security based updates that are like critical updates that a lot of them won't let you wait, you know, because some of them address major critical issues. But for the
So
most part, yeah.
what was the name? 2 years ago, a critical security update was necessary because the a company was able to do a coin mining using your computer just because of that security leak from Microsoft. I remember that, but I don't remember. It also had a name, but I forgot it.
I don't remember. Yeah. My work computer, the university computer is a Windows machine, but the primary computer that I use other than that is a MacBook actually. So
So you're rich, I think.
no, no. I didn't buy them here. I you know I bought them. It's a MacBook, but it's 6 years old, so it's actually running quite slow at this point. So I bought it before we moved to Turkey. So I guess, oh goodness, that means it's over 7 years old now too. So we I bought it before we moved to Turkey. So unfortunately, it's quite old now, and it's actually the last OS update it made me do, or the last security update, something like that, that it made me do, it really resulted in it slowing down quite a bit. So to the point that now it takes over 5 minutes to load up to go from turn on to get to the login screen. So, anyway, yeah. So, all right. So we were talking about configuration management, though. So, so the main purpose of this of the whole idea of configuration management is not just, I guess, the whole point of software quality, the whole point of software process, software engineering in general is trying to apply engineering principles to the development of software. And so, you know, again, we're trying as much as we can to get away from what I oftentimes refer to as the way that first year programmers write software, the way that first year programming students write software. You know, my 101 students, I also teach the 101 class here. My 101 students, much like myself when I was a first year programming student, uh, we're given an assignment. We're saying write this code, and they sit down at the computer and they start typing. Right? Many of them don't make a plan on how they're going to go about uh, making the software that they intend to make. You know, then after a few years, we start realizing, one, that we need to plan things out. We need to not just start writing code, but actually maybe. In fact, I got to the point where I can remember for one class, I would I would have almost the entire program, and we wrote. I learned programming in C, and I can remember having almost the entire thing written out in my notebook on a piece of paper, C code, before I sat down at a computer to type it out. And don't know why I did that, but I wouldn't do that today. But it was the idea, I think, was being implanted for me that I needed to think about it before I sat down and type. Now, truth is, part of that, because it was so long ago, I did not have a personal computer at home to write this code on, so I had to use the lab computers. at our university, which oftentimes you show up at the lab and, there's no open computers because everybody's checking their email and checking their, this was before Facebook, so I guess they weren't checking that yet, but they were looking at websites and just watching stuff, and but if there was no computer available, I couldn't do my work, right? And so what I got into the habit of doing was planning it out before I sat down so that I would not waste time at the computer. So in the same way, the whole idea of the configuration management tool is, what I was getting at was, then eventually we start realizing that another important thing to do is to save, right? As you're writing your code, you save your code, right? I mean, nowadays, everything is auto-saved, right? If you're writing up a Word document, and your computer crashes, the battery goes dead suddenly, and you go to start it up again, you open up Microsoft Word, and what do you see? You see the same document. It says auto-saved, right? And it was auto-saved a couple of seconds before the computer crashed, right? Well, back in those days, we didn't have that, right? Back in, my university days, we didn't have a lot of auto-save features. So, we had to save frequently. And in fact, I can remember, so this will show how old I am. We did not have thumb drives to save stuff on. We had, I wish I had one here with me, but we had the 3 1/4 floppy disks. The 3.5 inch floppy disk. You guys, have you ever seen a floppy disk? Have you ever used a floppy disk?
Yes, I used.
I tell you, the joke is that oh, you have them. Good.
Yeah.
Does your computer take it?
Actually, I'm doing music, and I have a very old keyboard, a very very old keyboard, but it's a professional keyboard, and you can only save the rhythms in floppy disks.
Really?
Yeah, I have my music rhythms in here.
Wow, sweet. So you'll know the answer to this question. So many of my first year students, well, even the second and third too, honestly, but many of them, if I ask them, so how much space is on one of those, many of them don't know. They'll guess really much higher numbers than what's actually there. But look at it. How much space is on one of those?
1 megabyte?
Close, yeah, a little bit more.
Yeah, 1.44, I remember.
Yeah, that's right. It's 1.44 megabytes, right? So which is like nothing by today's standards, right? But I can remember, for me, like my projects, my term papers, my lots of things I would work on. I would save it to as a student, we had a shared drive. You had your own shared drive, your own network drive. I would save my file there. I would also save it to a floppy disk. And if it was a really important project, I would email it to myself as well as an attachment. That made for a few different problems. One that made for the problem of always having to remember where the most recent one was, right? Which one, are they all the same? Is there one that's more recent than the other? Right. But one thing was also, if a change was made to one of them, let's say I made a change to the floppy disk version at home, all right, or on a computer other than the computer at the university, right? Suddenly, if I make a change to that one at home, the one in my network drive on the university and the one in my email attachment are both now out of date, right? So, but if at some point later, while working on it, I find out that the updated version on my floppy disk is got problems. I've added lots of bugs to the software there. I can always go back and get a previous version if I go check my email, right? Or if I go look at that file on the network drive, right? And so that's kind of, in a sense, one of the things that configuration management is about being able to revert back to a previous version if we need to be able to keep these updated versions. So another useful thing that we'll talk about that talks about in here is this idea of branching as well. So right now I'm looking at slide, if you have the slides up, I'm looking at slide 8, the first principles, version, release, version graph. Really towards the bottom here, you have this whole idea of this branching. So sometimes we might want to change one part, like have one team that changes one part of the system and another team that changes another part of the system or deals with another part of the system. And maybe my team creates its own branch that is particularly related to the changes I'm making. But the other code that I'm looking at, the other parts of the system that I have access to, is also going to be the old stuff that the other team hasn't touched yet. But at the same time, they are trying to make changes to their part of the system. So I guess in a sense, imagine if we were working on a banking system and one group was in charge of updating the personal accounts section as far as money transfers are concerned, like money transfers between two people's personal accounts. And another group is in charge of dealing with the investment accounts and dealing with how interest gets calculated and added to an investment account. Well, we can each work on our own, have our own branches that we don't have to have access to what the other team's working on, especially because it's possible that while we're working, things that we're changing may be causing problems for their side of things until we're done. So we have these two branches, and then at the end, we can merge them back together. And this is especially useful for, let's say, my side of things, my part of the system, it has a deadline of 2 weeks from now. So my team has to be done in 2 weeks. But the other side, their deadline is a month and a half from now. So they have a month and a half to, because their project, their changes that they're making are much more complicated, much more involved. So they need more time to do it. Well, if we were both working on the same set of code, the same system, and it was all just the same thing, then before I could release my stuff, we'd have to wait till they were done, right? Because anything that they're doing in the meantime might not be complete, might not be finished, and so it could mess things up if they got released too early. So what we can do is, when I'm done in my 2 weeks, because I meet my deadline, we can release a version of the system, a version of the software that includes my changes, but doesn't include anything of what they've done yet. Right? And so the user, the customer, can get access to the change that needed to be done in 2 weeks, and they can be done. Then later, a month later, the other team adds their stuff back into the repository, and that branch that they made becomes what we call merged. So now we're merging our changes with their changes into one new baseline. And a good version control system will be able to handle that pretty easily. This whole idea of branching and then merging back together. So what other thing that I want to point out? I went through this and kind of made some mental notes about what I wanted to say.
Have you seen the picture I shared though?
Not yet. I saw you posted something, but I need to see. Oh wow. Let's see what does it say on it? Windows XP. Windows XP Pro automatic. What is that? Automatic saving? What is that?
Installation.
Installation. Ah, nice. So that Windows XP was on a floppy disk, huh?
Yeah, it's interesting. How could Windows XP was fitting?
No, it's not Windows. It's just like maybe script or small program for being able to install Windows XP automatically. If you remember, Windows XP asks several times like keyboard options or username, password at the several times during installation, I mean. So
That's right.
that, yeah, there was a tool for automating that.
Oh, that's good. Yeah. Man, yeah, that was a long time ago. 1.44 megabytes. Yeah, actually, there was a. Go ahead. You were gonna say something?
No.
There was a story involving a disk like that. That when I was in university, I worked the tech support help desk for the university. There was a tool that we had on one of the computers that was called Norton Disk Doctor, and you could put a floppy disk like that in there, and what would happen is it would try to find bad sectors on the disk, and if it found them, it would try to recover the data and move it to a good sector. And so anyway, there was this woman that came in, and she was a graduate student, and she had a disk that she wanted to see if she could recover what was on it. And so I put it in the disk doctor, and it was one of those things that it took a few minutes, like 8, 9, 10 minutes to do all that, especially depending on if the disk was really bad. And so while we're waiting, we're just chatting, and I'm asking her what's on the disk, and she says it's her thesis. And I was like, oh, well, I really hope we can recover it. And then it finished, and you couldn't because the computer that had Norton Disk Doctor, it was a DOS machine, it wasn't a Windows machine. You couldn't like pull up a Word document like that. So I take the disk out, and I very slowly, very carefully move it over to my computer, put it in, open it up, and see the temporary file that gets created. Open it up, and I show it to her because I see a bunch of text on the screen. I show it to her, and I say, does this look right? And she said, yeah, but all the formatting is gone. Like, the bolding and underlining, it's just the text. And I said, yeah, but you got the text back. Like, it's a good thing. You should be happy. Especially because during the talk, I had found out that this was the only place she had saved her thesis. She didn't save it on her computer at home. She didn't save it on the network drive at the university. She hadn't, like I said before, she hadn't emailed it to herself. This was the only place in the world that she had this thesis in existence. And so I immediately took the file. I said, what's your email address? Pulled up an email, sent it to her, attached the file. I said, you need to save this. First thing you need to do is you need to save this in multiple locations so that if this happens again, you don't just lose your thesis. So good advice for you guys too, I guess, maybe, when you guys start writing your thesis as well. Let's see. Still trying to figure out. Yeah, so we also next week's topic, so looking at slide number 22, talks about verification and validation. We will talk about VNV next week as well. But basically, so verification and validation, they sound like they might be the same thing. They're slightly different. Verification is making sure that the configuration matches what we planned the baseline to be. So it's making sure that what we want the code to be like, that it actually it is what we planned it out to be. Validation is more about making sure that it matches the requirements. Right. So in a sense, it's like verification is kind of making sure that the output matches the design. Validation is making sure that the output matches what the requirements were, at least according to that definition. We'll look more in detail into VNV next week. I will say one of the things about configuration management that can be hard is, and as with anything of these software quality and software process things that we've talked about, that we will continue to talk about, one of the hardest parts is getting buy-in by your employees, by your team members. That people don't like to change how they've always done things, right? And especially because nothing comes for free initially. No change is costless initially. So a lot of times things will cost something to make a change, even though we can look at it and see that it will likely result in savings and less cost later on. Sometimes it's hard to justify making some type of change now. And so as far as configuration management is concerned, as a programmer, as someone who was a programmer when I first was introduced to the whole configuration management system, configuration management tool that we were using, it's like, so I can't just start working. I can't just start writing the code. Like I have to go email this guy who's not even a programmer, who doesn't understand what I'm trying to do. I've got to email him with, well, first I have to write up this form, this change request form, right? That lists out all the changes, all the files I need access to, connects them back to a design document heading, or a design document component. I've got to make this document up. Now I have to take it and I need to send it to him. I have to wait for him to see it, because what if I send it? What if he and I don't work the same hours that day? What if I send it to him after he's left for the day, right? Or what if he's at lunch, And so now I've got to wait for him to see it. Then he's got to send it back to me, and then he's got to confirm that everything's been written correctly. He releases the document. I get access to it. Now I can finally start writing code, right? To a programmer, to me, it sounds like a whole lot of red tape, a whole lot of bureaucracy, right? A whole lot of extra work that prevents me from getting my job done, right? But now that I'm on this side of things, now that I'm used to that, I became used to working that way. I realize now also how much that saved us from messing things up, because the truth was there were some times that what would happen is another programmer might want access to the same file that I was working on, right? But they had to wait. They had to wait for me to finish my work on it. Well, in a non-configuration management system where we just have a shared drive, maybe, right? A shared drive of documents. If we all work with the same documents, their changes could have overwritten mine, right? I'm sure you guys have you ever worked with a shared document before where you make changes and save them, and somebody else is like, wait, where did my changes go? Right?
Yeah, Google Drive.
Yeah, exactly. Right. At least with Google Drive, you can kind of see who's like typing, right? You can see the little, they have like a little note. This is the person that's doing it there. Yeah. I remember my, go ahead. Someone else was about to say something.
Okay. So, well, thanks to game engines, we are very lucky. We can easily send our all workings to cloud, and we have also version control. So if I did some changes, and if my friend was also working on the same document, he can easily see it. He can review my changes, and if he wants, he can upload his version also. And if he wants, we can always revert back. With all things, we are very lucky. But in other apps I used, the version control is not that good. I think we are very lucky in game industry.
Yeah. I think especially, I would imagine the game industry has to have something like that because of how much overlap and how much of working together there has to be there. Really, I would say that the programmers, some of us older programmers, that had a harder time being able to accept the whole idea of configuration management and version control systems. A lot of it stems from that we didn't work on the same parts of the system as other people a lot of times, that we worked on our own stuff. And so there wasn't a lot of overlap. There wasn't a lot of where if I made a change and saved the file into the drive, where it would overwrite somebody else's changes. There wasn't a lot of that, but but it could happen, right? Like you said, Tahir, you have the Google Drive, and yeah. So I know that with like the Google document, my wife we were working on something for one of my son's classes, and he like basically it was like a shared spreadsheet, a shared Google sheet, and somebody else was like, he would type stuff in, and somebody else would come behind him and delete it. He'd be like, "Where'd my stuff go?" So, uh, so version control helps prevent that, right? Because only one person will be allowed access to the file at a time, right? Yeah. So you know this, I think so one of the terms that we want to make sure we know, like some of the terminology we use, like repository. Repository is where all the baseline files are. So it's all they're out there. I think you said in the cloud, right, out there. That you guys have your repository is basically the cloud, yeah.
Yes.
And so that's where you get the files from. You can also have a local copy, right? That's what I did. I kept a local copy of all the files. We used a language called Power Builder, and so all the Power Builder files, I had a local version of everything. So the plus side to that was if I wanted to play around with some changes and see how they affected things on my own local system, I could. And then if I ever wanted to say, okay, but I want to revert back to what is current, I could always just re-download from the read-only side of things. I could re-download everything and get rid of all my changes there. And then also, if anybody else was messing around with, was also making changes to their version of the code as well, they wouldn't mess with my stuff. They wouldn't be changing anything on my local copy. So some other terms I want to make sure you guys know. Checkout. So checkout is when you're able to get an item from the repository, right? So you take that file and you make it to where no one else can have it, right? No one else gets to make changes unless you're the only one that has update access to make changes to it. Check in puts it back into the repository with the changes that you've made, right? You can also do so like in the version control system that we had, we also did what was called we also had an option to undo checkout. So this would be if I checked it out, I made some changes to it, I realized that I just completely messed it up. This, in fact, I realized actually this would be like where I realized this wasn't the file I needed at all. This was not anything related to what I was trying to work on. And I've made changes that should not have been made. Doing an undo checkout would then revert it back to a read-only state and make it to where it was the original version of it. So it would take my version and just completely throw away the changes. Let's see. Yeah. Yeah. Some of those, especially the issues. I would like you go ahead and make sure you understand some of the issues of the configuration, maybe some of the problems that come up. Because what is it? Buy-in isn't the only problem. There are some issues such as deadlock. There's one of these slides talks about the deadlock that can happen. Let's see, where was it? Right. So when someone retrieves the configuration item for modification, if two developers try to gain access to it at the same time, try to check it out at the same time, it can cause issues. Especially because a lot of times, I think on our system that we use, if I went to go check it out, it would oftentimes involve a series of yes, okay, dialog boxes where I would have to click to make sure that I understood you're checking this out. Yes, you're going to make modifications. Yes. you're going to lock this for everyone else? Yes. And I had to keep clicking OK. Well, what if somebody else gets involved in that process as well while I'm starts theirs and while I'm in the middle of clicking OK through mine? We can have this situation where it's like, oh, you can't have it because somebody else is trying to get it at the same time. All right. So was there anything else I wanted to specifically point out? Yeah. Oh, the other thing is one thing I did want to note as well is, so in our system that we used, it was not just the code that was included in that configuration management system. Every file related to the whole thing. So even like the design documents, the requirements documents, what else? The test cases that we used, testing documents, all the documentation in terms of user manuals, all of that was included in that repository. So we had everything in there so that it could all be part of the same configuration management system. All right. So if me as a programmer needed access to a code file, I would get it. If at the same time I also wanted to update the user documentation because something about what I was changing was going to also change how they used the system, then I would also need to also gain access to that as well. So that was very useful that everything about the system is not just about the software. It's not just about the code files themselves. It's the whole system can be included in that configuration management tool. All right. So that pretty much covers everything I feel like I needed to point out from the slides themselves. So what do you guys what do you think about the whole the whole configuration management? So Alper says he likes using it, right? At least for the gaming industry, he likes using version control systems.
I can't imagine working in a project because we are also lucky because in my university time the cloud was a thing, the version control was a thing, and we grow up, we learned computer engineering with those. So they are like a must to me. It's like they are like default. I can't imagine without version control or configuration management. No, it's impossible. For example, especially in game industry, there are designers. They don't know what coding is like because they only draw shapes. They are responsible of the visual effects, for example, and think that they have access to all the code files and like it's a disaster.
And are they earning money also?
Yes, of course. Sometimes they are earning more than the engineers because there are. I worked with a very talented graphical designer. He was like very good.
Yeah, there's all types of different talents that are needed for. And not just for the game. I imagine for the gaming industry, especially, you have to have graphic designers. But even it's just interesting to think about all the different people and different types of talents that are needed for different industries. My brother-in-law, my sister's wife, he's a graphic designer, but he works for a hospital, and so he's really been busy during this whole pandemic stuff because he's been in charge of like writing, like getting drawing the different graphics for a lot of their press releases, that revolve around how to keep yourself safe during the pandemic and stuff like that. And so he's a graphic design artist. He could probably have gone work for a gaming company, but instead he's drawing pictures of coronavirus, and so so just the different
So is he specialized on industrial design?
I don't know. He was mostly a lot of his work before he worked for the hospital was related to like logo development, like specifically like for businesses and stuff to come up with logos or other types of drawings for their advertisements and stuff like that. So yeah, he's not so much on the industrial. He like I said, he gets to draw. I think he draws pictures of the virus and draws pictures of people. I don't know. I'm not sure what all he does.
Okay. So because in the gaming side, the designers must also be responsible for rig animations, joints, and sometimes even they sometimes even work with vectors. And there is also another work group which is called as technical artists. They are responsible of shader codes, and it is like it's very very hard. But there are very less technical artists in the world itself. There are not many people who does that.
Mm-hmm. So.
But yes, it is great. So the configuration management, because we don't know how to design, and we don't have access to design elements of the game, and they don't have access to the code elements of the game, which makes everything greatly coupled each other. We cannot break their work, and they cannot break our work. So it's a must. I can't imagine without it.
Yeah. Yeah, and what you just said is exactly like what I was saying earlier about where they can make changes without negatively impacting your work, right? And you can do the same. And so yeah, it's great. So all right, so configuration management, like I said, is not a whole lot to discuss on this because I mean obviously for the Alpair you've used it, you are using it, and so you have some experience with a version control system. And the nice thing is, like I said, is for someone to be a configuration manager, they don't necessarily have to have any technical knowledge, right? They just need to be able to follow the process of what's laid out. Like I said, the guy that we worked with he wasn't a programmer. He didn't have a lot of technical knowledge, but what he did do well was he was able to take a look at the document, say, okay, he needs access to these 3 files. He can connect it back, and what he kept track of was how the requirement. One of the things that his job was mainly about was being able to connect a requirement from the beginning and be able to follow it through the software development process until it gets to the output of what we give to the customer, right? So you'd follow a requirement. He would have in his documentation how it connected to a design component, how that design component connected to a software component, how that software component connected to a test, because any change had to be tested. So how it connect to a test or a set of tests, and how those test results connected with that software component connected to a build item that was then released out to the customer. And so basically that's what configuration management is all about, is making sure that what gets out to the customer, that's what software process and software to engineering is all about, is making sure that what gets out to the customer, to the user, follows from the requirements that were initially stated. So, all right. So what I'll do is I'll go ahead and we can end there for today. I do want you guys to go ahead and take a look at those links that I sent you. And what was the other one I said I was going to look for? Oh, the ACA. Right. So what I'll do is I'll find that article that I read a few years ago about the Affordable Care Act in America, and how the software development problems that were encountered towards the end of that negatively resulted in a rollout fiasco. It was really quite problematic when that came out, and so I'll find an article about that and I'll post it here later today. Okay. So, anything else you guys want to talk about before we can cut the meeting and end the recording? No?
Okay, no. Thank you very much for the lecture.
Sure. Oh, and make sure you write the summary, the if you haven't already, the summary of those papers. Okay.
Okay.
All right. See you guys next week then.
Goodbye. Thank you.
See you.